I'm going to use StatKey to demonstrate how we can construct a sampling distribution when the population values are all known. StatKey is an open access application, which means that it is free and available for anyone to use. StatKey offers two sampling distribution simulations. For quantitative variables, we would construct a sampling distribution for a mean. For a categorical variable, we would construct a sampling distribution for a proportion. Let's look at an example of constructing a sampling distribution for a proportion. There are a number of datasets built into StatKey. The default here is the college graduates dataset. Let's start by working with this. There's more information about this data in example 3.1 in your textbook. Essentially, you have census data that found that 27.5% of American adults have a bachelor's degree or higher. On the right, we can see our original population proportion was 0.275. This means that when we draw our simple random samples, they're being drawn from this population with a proportion of 0.275. When constructing a sampling distribution in StatKey from a known population, we can change this population proportion either by selecting a data set or editing the proportion. Here, you can enter any proportion between 0 and 1. We can also change the sample size. The default sample size is n equals 200. For this example, I'm going to change it to n equals 100. In this example, we have a population proportion of 0.275 and a sample size of n equals 100. These are the two things that we need to set in StatKey before constructing a sampling distribution for a proportion. Let's begin by generating one sample. On the right, we can see our first sample, where 21 out of 100 had a bachelor's degree or higher. This gives us a sample proportion of 0.210. This sample proportion is represented by this dot. Let's generate another random sample. On the right, we can see that in our second sample, 28 out of 100 had a bachelor's degree or higher, for a sample proportion of 0.280. This second sample proportion is represented by another dot on our sampling distribution dot plot. The triangle and the number below it represent the mean of this distribution. We could keep generating one sample at a time and plotting the sample proportions one by one, but StatKey has the option of generating 10 samples at a time, 100 samples at a time, or 1,000 samples at a time. I typically like to generate at least 5,000 samples total to get a good picture of this sampling distribution. In addition to being able to see a visual representation of the sampling distribution, in the upper right-hand corner of our dot plot, we're given the number of samples that we took, the mean of this distribution, and the standard error. The standard error is the standard deviation of this distribution. Note that this method of constructing a sampling distribution requires that we have all of the population values, or in this case, the population proportion value. In most cases, we don't know all of the population values. In those cases, we use bootstrapping methods, which you'll see next in this lesson.